All right, so here we are, question 14. We've got 4% of eggs produced and sold by a local farm are cracked. Jerry buys 24 eggs from the farm. Okay, so let's see that here. Find the probability that exactly 2 of Jerry's eggs are cracked. So this is a binomial distribution where we have 24 trials and a 4% chance of them being cracked. And so then that means that the probability that exactly 2 of Jerry's eggs are cracked comes out to be 24 eggs. We're going to choose 2 of them to be cracked. That happens with the 0.04% probability, or 0.04 probability, not percent, and a 96% probability of them not being, so that'd be 22 uncracked eggs. Okay, so that's the formula. You can just type that in to the calculator. And turns out to be approximately 0.180, because I rounded up from 0.1798. Okay, then find the probability that Jerry buys no more than 4 cracked eggs. And so let's see here. We can use a probability distribution. We have the binomial distribution, the binomial cumulative distribution function on the calculator, the CDF, to find that they have no more than 4 cracked eggs here. So we're going to type in 24 trials with the probability of 0.04 and no more than 4. So that would be probability of 0, 1, 2, 3, or 4. So we're going to type in an x value of 4 and see what that spits out. And that says a probability of 0.9977 right there. And that's the probability of buying 0 cracked eggs. Let me just double check. Let's see. That can't be right because it's got to be. What's wrong with that? Find the probability that Jerry buys no more than 4 cracked eggs. So what's the cumulative distribution there? Let's see. What if I do 0? Let's see. Yeah, that makes sense. So the the probability of there being no more than 4 cracked eggs comes out to be such a high number because you're adding them all up. What does that mean? Does that work out? Yeah, no, that works out. I just second guessed it because it's such a high number, but that is the idea. Find the probability that Jerry buys at least 2 cracked eggs. So for that one, if you buy at least 2, what you can do is subtract the probability that you have 0 cracked eggs or 1 cracked egg. And if you type in the binomial cumulative distribution function, you'll see there's a 75-ish% chance that there's going to be at least 2 cracked eggs. And so you can just go 1 minus 0.751, and that gives you 0.249. And then to find the variance in the number of cracked eggs, there's a great formula for binomial distributions that the variance is equal to NP1 minus P. And so here we have 24 eggs times 0.04 times 0.96, and then that pops out to be 0.9216. And there you go. If we wanted to round that to three significant figures, 0.922.